before we begin, I would like to point out that there's this book called Junqueira's Basic Histology, and it's a very good book. It's a recommended book for medical students, which covers most of the important topics that you're expected to know for licensing examinations, such as USMLE or PLAB. And in this series of lectures, we'll be following that book so that we don't leave out anything and we cover whatever you're expected to know for those licensing exams. All right. So let's begin with chapter 1, the epithelium. The epithelium comes from a word called epi. And epi translates to on or upon. So something that covers is on or upon another thing. That's something that covers another thing. So in medical terms, you'd say that, for example, there is an organ, all right? And there's a layer of tissue that's covering it, and this would be your epithelium. All right, so a good example of this would be around the heart. So let's assume this is the heart, all right, and there's a little layer of tissue that covers the heart, and we've studied this in anatomy. It's called the pericardium. All right, and this is another example of an epithelium that covers, basically, an organ. There are other examples of epithelia that we'll go over later in this lecture, but let's go over the features of what makes an epithelium. Epithelial tissue is basically made up of aggregated cells. So let's assume that this is the pericardium. It's made up of aggregated, closely tied cells. And these cells are polyhedral. That is, that they have faces, many faces, okay? So let's assume that this pericardium that we've got here, this is the heart side, and this is the thoracic cavity. All right, so on this side you'd expect the epithelium to be exposed towards the thoracic cavity, and this side you'd expect it to be attached to the heart. And polyhedral basically means multiple faces. So this side of the thoracic side of the pericardium would have the apical face or apical domain. All right, so apical, and on the sides it's called the lateral domain. And on its base, it's basically called a basal domain. So an epithelium is made up of aggregated polyhedral cells, and they have these multiple faces, the apical side, the lateral side, and the basal side. And all of these faces may be modified according to the tissue that the epithelium is present on. For example, certain modifications may allow the cells to be better at, or allow the epithelium to be better at secretion. Other modifications may allow the epithelium to be better at absorption, etc. So following this example of the covering epithelium, that is the pericardium, a good example of an absorbing epithelium would be, for example, in the intestines. So inside the intestines, we've got this epithelium on the inside of the intestines that is more suitable for absorption. All right, and this epithelium again consists of aggregated polyhedral cells that has modifications on its apical surface for absorption. All right, so these things are called microvilli, by the way. We will study them later in this chapter. These are more suited towards absorption. A good example of an epithelium that is more suitable towards secretion and motility would be the respiratory epithelium that we've got right here. This is a good example of an epithelium that is more suited towards the functions of secretion and motility. As we can see here, it's got these cells right here, goblet cells they're called, and they secrete mucus into the respiratory lining, and it's also got these modifications on the apical surface of the cells. These are called cilia, and they are responsible for the motile movements that remove the cilia from the respiratory tract that is being secreted by the goblet cells here. And again, as we can see, that these are aggregated cells and they are polyhedral. They've got multiple faces, and all these faces have their own specific functions. So all in all, in conclusion, we can say that epithelium is made up of aggregated polyhedral cells, and that these aggregated polyhedral cells have cell polarity. This shows cell polarity is that they have these apical, lateral, and basal domains, right? And these cells are suited towards certain functions that we have learned. For example, the function of covering, for example, that we did with the pericardium. So let's get covering in here. Absorption, like we did over here in this case of the small intestine. Absorption, contain microvilli for absorption. Secretion, such as the respiratory tract that we did right here, the goblet cells, and motility using the cilia right here. All right. Now let's take a peek at our neat notes, just to be up to date with what we have studied so far. So basically, we have studied the epithelium, what that is. It contains aggregated polyhedral cells. Below ECM, we will come to that later, but it has this cell polarity. It's got the apical, lateral, and basal domains, right? And its functions, for example, the covering and lining that we did with the pericardium, its absorption, we did for the small intestine, secretion, motility, and sensory. We will come to that later when we study the modifications as they are. So far, so good.